As you can see, I've got a breadboard. I bought electronics kit off the computer, off the Wi-Fi. Excellent. Got electronics kit. Electronics fun kit. Absolutely smack packed full of everything. So I got a breadboard. I've been learning. I'm trying to understand what a volt is, 2 current, and what a version of the ohms is in resistance. If these them in 100k, so them 100,000 ohms. So whatever it is divided by 100,000. Yeah, divided by 100,000. So that's 100. So I've been learning anyway, and I've learned that the resistors, them in 1 mega ohm, them in 100k, 10, 5, 2, 1, 330, 220, 100, 10. And I got it wired up. 5 volt supply, positive, negative. Comes to there. Goes through the lamp. If you can see. Goes through the lamp. Through the resistor, up this wire, over, onto this line, through that resistor, up and over, onto that line, up and over, onto that line, up and over, onto that line, through that lamp, up the positive wire, into the positive terminal. That's the general current flow, acceptance of direction. If the voltage is the potential difference of the current to the resistance, which is the amount of ohms. And I'm trying to work out if the resistance is 3/4 the actual resistance not used, and only 25% of resistance is used, and 25%, which will be positive gain, is used in the chemical substrate of the resistors as the down trough of the sine wave. They mean nothing, they mean. I just how I store my wire, so if I need a wire, I just, rather than keep going over there and getting and fetching. But here, as you can see, I've got my resistors, so smallest to largest. If I put it at 1 mega ohm, I got 5 volt supply, it's running at 5.4. But I think, as well, the multimeter, instead of giving a reading through a scale, it gives a reading from a memory address. And in the memory address is a stack of readings of range of graph ranges and such like, and so it's a real reading, like one of them with the the magnet and the spring and the coil that moves backwards and forwards. You can see the flow, but you don't get the response of the quickness of the digital, where the signal is I constantly. So that's 500,000 ohms in that little range, in that continuous serial line of resistance. If you measure the voltage, if you take the power out and bring it to just the 100, there's the negative, there's the lamp, across the lamp, through the resistor, 100,000 ohms. See how bright it is. We are. That's quite bright. So that's 100,000 ohms resistance, 200,000 ohms resistance, 300 ohms resistance, 400 ohms resistance, 500 ohms resistance. You can only really tell on the video between. Let's see if I can't. No, you can see a little bit. So, and you got the current flows through it. So we got the current. It dims and as it goes up, and there's the two complete the circuit. Then even dimmer. Then if you just put the positive on this side of the of the lamp, so the resistor's positive. It's like the polar of a magnet. It's like, if you can imagine a rectangle and a slope bisects that rectangle. That's the potential difference, the height of the angle down to the next angle, but it's counter by that angle. And that's sort of all relativity and general relativity and everything like that, it. And what my plan is, I've noticed that the voltage across the resistors is from there to there, that continuous line, serial. That continuous line reads 5.4 volts. If I go to there, the fourth at 400k, that's at 500k, 5.4 volts across the entire lot. But if I go to 4 volts, sorry, to the fourth resistor, 400 ohm, which is this one here, I think it's about 3.7 volts. And if I go to here, the third resistor at 300 ohms, it's 2.7 volts, 1.7 volts, 1 volt. That's the voltage drop with the total resistance 1, 2, 3, 4 that add up to the resistance behind this top resistor, which is 100k in its own right. So you got 5 volts meets 100k, 400k behind it is reducing the current each time. So you end up with 1 volt at the top, 1.7, 2.7, 3.7, 5.4. when I put the voltage when I measure the voltage, now see the multimeter's off, is off. There's no current flowing. There's the wire. So why, I was going to explain, as I put a voltage meter across each resistor, 1, 2, 3, 4, 5, it means 1 volt, 1 volt, 1 volt, 1 volt, 1 volt. That's 5.4, that's the 5.4 volts basically. There's some loss. It works out to about 4.7 volts when you add up the totals. But why is it keen? Why does it light up? Preferentially, when I put this multimeter, let me see if I can find something else. I'll try the negative. Yeah, it does it with the negative, so it's a shorting meter, giving out current. That's nothing. My meter's it's my meter's switched off, as you can see. Look, off position. That's pretty much off. So I'll take the lead out. There's nothing. Now does it? Now does it light? Yeah, it still draws current, so it's keen. So in the mechanism of the electricity being of a volt and a current, a length of, and a volt being a short, is the weight of the potential difference of the current. It's the weight, but the current exists because there's a circuit, I think, whereas the volt exists because of the natural measure of ethereal, whatever you call space and time, in your own words. Ethereal is the space and time. What is it? It's keen. See, I'm making a circuit from, but what I'm saying is, as you can see, it's a dangling cord. I ain't shorting. I'm adding something to the circuit. Does that get brighter or darker when I do this? It gets brighter. So when I do this, that should get a little bit brighter, and that even more brighter. Yeah. So I'm adding something to this circuit. 5 volts is the potential difference between the negative and the positive. And if I do the middle one, 1, 2, 3, 1, 2, 3, that's 6. How do you get that out of 5? Oh, would you believe it? Interdimensional aspects of space and time. After this, I'm learning about how to do it onto a computer. And then when I've learned how to do it on a computer, I'm going to use the principle of a balanced circuit, a tuned circuit, in principle of logic, and see if it picks up a resonance of nature, the ethereal realm. But what I want to know is, why is this lead causing them to light up brighter? That indicates that more voltage is being applied, or more current is being drawn. Now it don't matter if I put it on that one, or that one, or the middle one, and they both equally light up, or is it what they call ground? Is this acting? I think I've read a bit about electronics over the years, but I've never really got into it. That's why I bought this electronics kit off Elegoo. Bought it off the computer, off the Wi-Fi Primal. Brilliant, mate. Thanks, Society, technology, and everything for this. I just think I could have nothing. I've had the most greatest thinks and depths of thinking, just off the principles of that line of electricity happening, how it comes about, how it's transferred into time, how time accommodates it, can represent any part of that time and call upon it at any part of that time. That all goes on in that sort of a circuit. See, that sort of goes on. It must be acting as a grain. It happened with the black lead as well. Anyway, so I can plug that back in now. It happened with the black lead anyway, so it must be ground. But where it's drawing the current, does that mean, as long as am I drawing current from the lead? I ain't drawing in voltage, because voltage has to be generated, do it? Is generated by the potential of the current. And the current is well, that's what I'm trying. The next thing I'll learn in the next video is the length of time it takes for one current's worth of unit of structural pool of iridescent crust come about. Then that'll do for now. Hope you find it interesting.